Hello, good morning. Welcome to track 2 of day 1 of this conference. Our first talk is about how to have visibility and security of your CI/CD ecosystem, and the speaker is Pramod Rana, who heads AppSec team at Netscope. Over to you, Pramod.
Thank you. Thank you. Good morning, everyone. Like she said, I'm Pramod Rana, and today we are going to talk about how to have visibility and security of CI/CD ecosystem. Before we start, I would like to extend my gratitude to all the sponsors and the host. Without them, this conference would not happen. Any conference would not happen. This is the agenda for today. First, I'm going to set the context that why we are having this presentation, and then I'm going to talk about the attack surface around the technology. What is the methodology we can use as an organization, as an industry to overcome that challenge. And then I'm going to introduce one of my open source project, CICDGuard. Guys, there is a space in the front. And then we are going to deep dive into the architecture and the workflow of the CICDGuard. I have a live demo recorded with me, and then I'm going to close out with the going forward and the feature expansion of the CICDGuard and the overall security. First, bit about me. I'm working as application security manager with Netscope. I'm author of 3 additional open source projects: Omniscient, vPrioritizer, and SecDependEdder, which I have presented in few conferences like Black Hat, DEF CON, OS, Insomni Hack. I'm also OS Pune chapter lead and an OSCP. So just to set the context, let me start with the very simple version of the overall CI/CD ecosystem, how it works. So for any software developing organization, there is a set of code which is developed by the developers, which is stored in a central location. We called it SCM, Source Code Management Platform. And then we have a solution which converts that source code into a deployable entity, which is again stored in a central location. And on top of that, we have a solution which converts that, which distributes that overall binary and the deployable version into the different infrastructure. So this is a very high level of any CI/CD ecosystem which works in any organization, any software-based organization. And as a security and as a software developing company, we should have a security check embedded into each and every phase of the software development lifecycle. We call it security in CI/CD, as we all know it. A great topic, but today I'm not going to talk about that. Today, I'm going to talk about securing the building blocks of that CI/CD ecosystem, and which as we know it, security of CI/CD. So in today's time, there are a lot of technologies in each of the space when it comes to the different phases of the CI/CD, and more often than not, each technology falls into more than one category. And like any other ecosystem in the nature, impact of even a smallest component of the part of that ecosystem impacts the overall system. And just to give you the idea of that, the problem with that is the security, and like I said in the start of the title, it's the visibility part as well. So how many of you are working in a product-based organization? And let's say how many of your organization is using GitHub Action as in any capacity of the CI/CD ecosystem? So is there any way for, I mean, in my organization also, we are using a lot of actions, third-party GitHub Actions. So let me ask this way: is it possible for us to know at any point of time how many external GitHub Actions we are using within our organization? Anyone? And even if let's say in a best case scenario we have that visibility, is it possible for us to know that what version of those third-party GitHub Actions we are using in our environment? I know there is a talk in OS in OS New Zealand only, which talks about how to exploit the GitHub Actions, the custom GitHub Actions. And there was a wonderful talk in the OS Dublin as well, which demonstrated that how the external GitHub Actions can be used to Bitcoin mining and other kind of proxy features. So that's where the overall the security of CI/CD system lies, where it's the security and as well as the visibility part of the overall ecosystem into come to the picture. Before we further, I'd like to say that I prefer to have question at that point of time only rather than holding some time in the end. So if at any point of time you have any question, please raise your hand and we'd like to discuss it that point of time only. So if I have to explain few of the attack surface, these are just few examples which I have observed personally, across different organizations I have been part of. I'm sure there are thousands of other examples as well. So in these attack surface, I'm trying to highlight the relationships of different components, how it works. For example, in this case, I just demonstrated that how a trivial vulnerability, which is as good as small as, let's say, a default credential running in the Jenkins. But the complexity of the attack is that how that Jenkins server is getting used in order to develop the software in your organization. So in this case, for example, if that Jenkins job is building a binary which you are eventually distributing to your client or your customer environment, and I'm sure you will all relate that whenever something is going to the customer environment, that gets more you say deep down security vetted than any other part of the solution. So a very simple, I'll say very trivial vulnerability as good as default credential in the Jenkins could have impact to the systems which you are distributing to your customer environment. The example which I just demonstrated, the malicious vulnerable third-party actions, and it's just not related to the action. I just picked that as an example because we are using extensively that. It could be malicious plugins into Jenkins, or it could be a malicious plugins into any other, let's say GitLab or any kind of CI/CD platform. Another example where we have one user distributed, in a typical SSO environment where one user is present across different systems, and if we are able to if the attacker is able to compromise one part, then how it's going to impact the other part as well. And same applies to other things as well. So what we can do to handle this kind of solution. So what I was able to do is I was able to break down the methodology into 3 parts. The first is making the technology, making the part of CI/CD, making the technology secure by itself. And what I mean by that is, in any software, in a software ecosystem, there are always 2 parts to it. The one who is building it, the other one who is consuming it. The first part relates to the builder part, and again it will ties back to the security in CI/CD ecosystem. So as a software provider, it's our responsibility to make sure that we are delivering the most secure software possible to our customers. That is the first step in the methodology of securing this. The second aspect of that is using that software, putting the effort while using that software, which is basically the software consumer part. OS as the community is doing good job, helping everyone to make sure. So, but what I mean by that, let's say in our organization, we have a policy that whenever we are using a open source software, we put our due diligence in order to make sure that the overall third party, that library is secure to be used in our organization. So I think if everyone in the community starts doing that, then eventually it will help to make the overall part of that system secure. So in the first point, there are 2 parts. The one actively involved as a software provider, which I think as an industry we already do pretty good at. The second part is about being the software consumer, and I think that's where we need to increase our efforts and put more efforts toward that. It could be, like I put the example, it could be implementing vetting process on organizational level, and that software can be anything. It could be a small library, open source library, to enterprise software which is used by everyone in your organization, for example Workday or something like that. So anything you are using which is not developed by you, You just put your effort, your best effort in order to make sure that that thing is secure. And whenever we identify something, work proactively with that vendor in order to make sure that, I mean, as a software consumer also, we can treat that finding or any security flaw as good as our product flaw, and then work actively with them. Second part of that this methodology is how well we are implementing it. So we can make best secure software in the world, but if we are not configuring or implementing or deploying it securely, it won't make any sense. So I think that will vary as per the organization to organization, and how well you are implementing in your another organization will depend. And it don't need to be any rocket science kind of configuration. It can be as simple as making sure that you don't have any default settings disabled. I think this recommendation will go back at least 5-8 years back, but still we identify these kind of cases in an enterprise level organization. MF enabled, these are just few examples. Up-to-date plugins, applications, actions. Most technology, if not all, provides a way to extend the capability of that particular platform. So for example, in case of Jenkins, it could be plugins, which helps you to extend the functionality of the Jenkins. And as we keep growing in our organization using that product, the more and more plugins the developer or the any other operation guy keep using it. So as a security professional, it's a nightmare kind of scenario where you just have the external plugins or external software or external code basically running in your organization, and you don't have any control over it. So as a security person, you just have to make sure that we are using that plugins, and it's necessary to use it in today's time, but we are using it in a best secure way possible. The third part of that, this methodology is monitoring and the responding to the security. I think I've been in industry long enough to understand that no matter what we do, we are bound to have security incident/issues. So in that case, how well we are monitoring our environment, and if we identified anything, then how well we can respond to that. So these are the three parts to the methodology. First, making the technology and the software secure by itself. There we have to play the role from both sides, being a software provider and the software consumer. The other part is implementing it well, using all the security configurations possible, and then third, be prepared for any security incidents we might face in the future. Any question till this point? Okay. So around this, I'll say around this problem, I developed an open source product. I call it CICDGuard, which I'll say there are three key highlights of that open source product. The first one is the visibility part, which I said personally as a security professional I find most challenging, the visibility part. What it does, it breaks down all the CI/CD technologies. At this point of time, it supports 4 technologies: Jenkins, GitHub, GitHub Action, and JFrog. It breaks down all supported technologies into multiple components, and then each component is represented as a node in the graph, and then the relationship between the nodes is represented by the edges. So each edge will represent a relationship between the different nodes. So what happens by that is that each of the technology is converted into graph, and because of the inherited nature of the graph, it's relatively easier to map out the relationships and look at the overall inventory in the overall CI/CD ecosystem. And the relationship, it's not just within the technology, it's across technology as well. So what I mean by that is, so let's say GitHub Action will be break down something like this. You have workflows, you have runners, you have steps, you have another GitHub Actions called by @. But at the same time, it will try to find a relationship between a Jenkins job triggered by that GitHub Actions or in any other way. So there will be a relationship between different technologies as well. So in that way, it can help us to identify that if one part is compromised, how it's going to impact the other part as well. So that is the first feature, I'll say, where it breaks down all the building blocks into the graph form. Second is obvious, it tries to identify some security misconfiguration issues for all the supported technology at this point of time. Four, like I said, I'm actively working on extending it. And the third part, in which I just touched upon, one of the key features, I'll say, it tries to identify the relationship between the different technologies. So in that way, it can help us to identify that if one technology is compromised, how it's going to impact the other one. So for example, it's a very typical configuration that you have a change in a repository, let's say a pull request, then a certain Jenkins job will be triggered. So because of this graph, you can know that this repo A is related to job B of Jenkins server C. So in that way, it can build a relationship. I'll show you in a demo what I mean by that. Another use case which I tried was that how many external third-party GitHub actions I have in my organization, and how many different versions of each GitHub actions I have in our organization. So let's say this way. So in your organization, you might have a process where it says that whenever we are using an external GitHub action, it has to be vetted by the security process, and that process could be anything. Let's say you say that GitHub action A version B is vetted by security team. How can we make that governance part of that overall solution, that we make sure that in our organization only that version of that GitHub action is using? Or for example, there is a very typical security recommendation which says that do not use the master or the latest version of the GitHub actions ever, because that will mean if there is any change in the repository used by that action, that change will be directly propagated to your environment. So in that way, it can help you to identify that how many different variations of any third-party source code you have in your environment. How many common users across different technologies. So in this way, it can build that relationship. So three key features. First, it breaks down all the technology, represent that into form of graph, identifies few security misconfiguration across technology, and third, it tries to identify the relationship between the different technologies. Like I said, each of the technology is break down into the form of graph. So this is a typical schema of the database looks like. Like I said, I tried my level best to break down into the smallest component possible, so that we have more granular control over it. So for example, if you'll say in GitHub Actions, it breaks down each and every component defined by the GitHub itself. And in case of Jenkins also, it just doesn't say that you have a user or you have a member. It breaks down into that component as well. So this is the overall architecture of the CICDGuard looks like. Each of the component, I have coded it in a way that each of the component can be used independently. You don't have to use the entire solution in a single shot. So it will depend on your use case, how you want to use it, but each of the component can be used independently. And what I mean by that is, the most, I'll say, the active component is the scan engine, which is basically a bunch of Python scripts depending specific to each technologies. So for example, if in your organization you are not using JFrog, then there is no point of running that scanner, right? So in that way, each of the Python scripts, which is basically a scanner for that technology, can be used independently, and each of the scanner will produce the output into, let's say, in your terminal or in your JSON format. So one use case could be you don't want to use any analytics or analysis or the node database, anything. You just want to identify whether you have any security misconfiguration in your environment or not. You just do git clone and scan the, run that particular Python script in your environment. So that is one use case, straightforward, easiest one. The second part of it is the analysis engine. What happens by that is, so let's say if you are running your one scanner, you have an option to feed the output into the Neo4j database, which is the backend database I'm using for the graph. So as you keep scanning the more and more technologies, the more and more analysis it will build out of it. So for example, first you ran just, let's say, one Jenkins server. It will not have any analysis at this point of time because there is no other technologies. Then on top of that, let's say you ran another Jenkins instance, but the Jenkins scanner only. And you put all of your data into the Neo4j database. Then it will fetch, the analysis engine will fetch all the data from the Neo4j and build the analysis between those two technologies. Now let's say again you ran the GitHub scanner and put all the data into again the Neo4j database. Then analysis engine will again pick the data from the database and then build the analysis between these three parts. And as more and more scanning you do in your environment, the more and more analysis it will build out of it. So scanners, bunch of Python scripts specific to each technologies can be run independently. At the same time, you have option to put data into the database, Neo4j database. Analysis engine will fetch the data from the Neo4j database. The more technology you have, the more analysis it will be able to build. In the output format, you have three types. Like I said, you can simply show in the terminal, put it into JSON, and have it stored into the Neo4j. The primary use case why I had it in JSON is it might be possible that you want to redirect that output into, let's say, your analytics engine, let's say Elasticsearch or something like that. Or maybe you want to have it integrated into your workflow and you consume that JSON format in any other way. And that JSON output will contain all the information what is available to the Neo4j database. On top of that, there is a very, I'll say, very basic web UI which basically helps you to identify the different nodes and the relationships between the whatever output your scanner is able to identify. And as you can imagine, in order to run the scanner, we will need a certain authentication mechanism to the target environment. There are two ways to identify that, input, that authentication detail. The one is the environmental variable and the other one is you can provide by the command line input as well. Yeah. Any question in this? Yeah.
Can you include Azure DevOps into this?
Sorry?
Azure DevOps.
By default, no, but one hack could be that you configure your pipeline in a way that it will fetch that script and just run it. You can call it as any other. I hope I understood your question correctly.
Yeah, like
as a target environment? Oh, no. At this point of time, no, but yes, I can have that in pipeline. But as of now, it doesn't support that.
But what would be the hack?
The hack I was trying to say that do you want to use those scripts into your pipeline? So for that, you just call it as an external script like you will do for any external part. Okay, so running out of time, so I'll be really quick in that. Like I said, I recorded the session because of the sensitivity of the data, so I needed to rectify the data, so that's why I recorded it, but trust me, it will run. So like I said, the scanners are a bunch of Python scripts which you can get into the certain directory. For this demo, I'm using the environmental variable as the authentication mechanism. Once it starts running, I intentionally kept the time as is because I wanted to show how much time it will take depending on the technologies. So in some cases, it might take more than the others. So it will keep just scanning, it will try to fetch all the database. At this point of time, it is putting all the data into the Neo4j as well. So this is the JSON format output which it will look like. And at the same time, it put all the data into the Neo4j as well. So this is the first technology I scanned. And this is the second technology I'm scanning. Again, I'm using environmental variable as the authentication detail. So I will fast forward it now. So it will happen in the same way. Oopsie. One second, guys. Yeah, I just wanted to show the web UI once. So it's a very typical execution time. So this is what the output of the database looks like. So once you are able to put all the database data into, and this is the very basic filter you have, you can select on the basis of the technology. The red one shows obviously the vulnerable ones. There is a color coding in the back of that, and as you are able to do that, you can filter it, you can select. One important thing I wanted to show is the relationship. Is the relationship between the two technologies. So the black one is the GitHub, and this bluish color is the Jenkins. So now it is able to build the relationship between the Jenkins build and the repository. So once you keep doing it, the more and more technology, like I said, the more and more technology you will build, the more and more relationship it will be able to make out of it. So this is another example which it was able to do. Because of time, we have to cut short it. This is anyway last slide. Going forward, expansion of the target technologies, like you said, let's say Azure DevOps or something like that. These are the three which I'm working right now. I can definitely include more. Expansion on the analysis engine part, the more and more analysis it will be able to build across technologies. I think the more and more value it will be able to provide, because of that we have the ability to know the blast radius and something like that. I'll say my third priority is the visualization, but I'll have a look at it. These are my coordinates. Feel free to reach out. Any question, I am available via LinkedIn, GitHub. Twitter is the least used, but I think LinkedIn will be the first one to reach out to. Any question? I think we have to sync offline because we are out of time.